Hey, my name's Brent. Welcome to 49cc Scoot. Today I'm going to be trying to fit a Yamaha Aerox front wheel on my Chinese scooter. My scooter already has an Aerox rear wheel as part of an RC1 engine swap, and I intended to put the Aerox front wheel on during that swap, but at the time I was trying to make it to a car show and I was in a bit of a time crunch, and when I went to tap the axle through to put the wheel on for a test fit, it popped one of the bearings right out of the side. There must have been some misalignment of the spacer and the wheel bearings that the axle caught on the way through, but still the bearing should not have popped out as easily as it did. I didn't put a lot of force on there or hit it very hard when it popped out. I believe this is because I had these wheels powder coated and the powder coater didn't do a great job in a lot of respects. One of the things that I believe they messed up is they media blasted the inside of the wheel where the bearings and the seals set, and I think that has changed the clearances for the bearings a little bit. Luckily, I don't think they removed enough material to ruin the wheel, but I definitely need to make sure the bearing sits a bit more securely inside of there. The options that I considered were shimming the bearing or using a retaining compound. The fit wasn't far off and still needed to be driven in, so I went with Loctite 603 retaining compound. It's designed to help hold parts that are press fit together, and I had some around. It's also a much easier process than trying to get a super thin shim to stay in place and not tear during assembly. The bearings on the wheel were cleaned, and then retaining compound was applied to the bearing and the inside of the wheel. Then I drove the bearing in as usual. I used the axle this time to be sure that the spacer in the wheel aligned well with both bearings. One good thing about the way wheel bearings are set up is that I wouldn't expect them to experience a lot of force trying to push them in or out of the wheel once all components are installed. There's a spacer between the bearings in the wheel, and then spacers between the bearings and the forks. I'm not saying I'd want a loose bearing fit by any means, but I think this should work fine with the amount of resistance that I had driving the bearing in, plus the retaining compound. Loctite 603 requires 72 hours to ensure a full cure, but I wanted to continue to work on the wheel and check fit. I gave it 24 hours to cure and then started working on some things that I didn't expect to put any stress on the bearings or the compound. I wanted to install the 220mm brake rotor next, which is the same one that I was using on my stock wheel, but the wheel needed some prep work due to the powder coating. Powder coating was built up around the bolt hole, so I removed some of that with a chamfering tool and later went around the inside shoulder area with a box cutter. The powder coating also clearly had high spots, so I used a file to flatten the mounts a bit. Ideally, all mounts would be totally flat and level with each other to give the brake disc a good mounting surface. That's not going to happen with just a file, but it's better than leaving it as it was. I went to install the brake and the bolts didn't want to start. I'm sure they could be forced in, but that's not a good practice. I took a closer look and I could see that there was a bit of powder coat on the top of the threads, and the threads were also rough from being media blasted. I'm really not sure why the powder coater blasted every bit of the wheel inside and out, but they wouldn't take any instruction on what not to touch, as they were supposed to be professionals. I guess I should have known better, because they coated my other wheels and coated right over the brake drum friction area, and I had to sand all of that out of there after also being told that they know what they're doing. I went through all of the threads with an M10 by 1.25 tap and cutting oil. I cleaned each bolt hole with brake parts cleaner and compressed air. I'm not a big fan of using harsh chemicals around the coating if I can help it, but I also didn't want cutting oil left over in the threads to possibly interfere with medium strength thread locker that should be used on brake bolts. Then I was able to get the bolts started by hand, so I installed the brake disc and torqued the bolts to 23 Newton meters. After giving the retaining compound more time to cure, I could finally get to test fitting the wheel. Basically, all I knew at this point was that the wheel could fit between the forks, but I didn't know if the brake rotor and caliper would align, so I installed the wheel without any spacers to allow it to move side to side. I moved the wheel till I could get the rotor to sit inside of the caliper and bolted the caliper in place. With the brake parts aligned, the wheel was way off center. There was a lot of clearance between the wheel and the fork on the brake side, and hardly any on the opposite side. I wasn't necessarily concerned about the wheel being perfectly centered, but I wanted it to at least be somewhat close. In an ideal scenario, the wheel would be perfectly centered with the rear tire for the best tire wear and handling characteristics. Initially, I thought about giving up on the front wheel swap and continuing to use my stock wheel. I assumed that the 13-inch Aerox wheel and the tire combo was heavier than the 12-inch setup anyway. I decided to weigh both wheels, including tires, bearings, seals, valve stems, and speedometer pickup magnets to see how much heavier the Aerox combo really is. The Aerox wheel weighed 17.1 pounds, and I was surprised to see that the stock wheel came in less than a half-pound lighter at 16.65 pounds. Seeing the small difference and preferring to have matching wheels made me reconsider fitting the Aerox wheel. There was also the added benefit that my 12-inch wheel won't allow me to remove the caliper without first loosening the brake disc because of clearance, but the 13-inch wheel allows for easier service. The brake rotor sits very close to one fork while the tire sits very close to the other side of the fork, so simply trying to change spacing of the brake components would not work for me. I would either need the brake rotor to sit farther toward the center of the wheel to fix this issue, or to swap in a steering stem with wider fork spacing. Aerox Bud from the 49cc Scoot forum measured his Aerox forks to be about 173 millimeters apart, measuring inside to inside edge. The same measurement on my scooter showed 151 millimeters, well shy of the Aerox. I looked briefly at steering stem options, but I was hoping not to put a lot of money into it, and not just any wider stem will fit, so finding the right one could take a while. Forum member Jack Rides mentioned milling the brake disc mounting area of the wheel to let the rotor sit further inboard earlier in this process. I initially dismissed the idea because the wheel is way too big for my mini lathe, and having a shop mill the wheel would be more expensive than I was willing to accept. I put a little bit of thought into it and came up with an idea that may allow me to mill the wheel myself. I have this piece that I made for my mini lathe. It's a chunk of 1.5-inch aluminum square bar made to clamp a handpiece for my rotary tool in that bolts on in place of the tool post. I've also made case cutters in the past that use a rod going through two bearings to secure a cutting bit and keep it centrally located and true. If I could use a combination of those ideas, I thought it could work to machine the brake mounting surface of the wheel in a manner that kept the cuts flat and level, perpendicular to the axle. I started by finding a suitable rod to go through both wheel bearings. It needed to be pretty much exactly 12 millimeters for a snug fit to eliminate as much play as possible. This axle is about 11.8 millimeters, and you can see how much play it allows. I could machine a half-inch steel rod down to 12 millimeters myself, but I found a 12 millimeter by 350 millimeter rod on Amazon for a little over $10, and that made more sense to me when considering material cost plus time, and it's machined to tighter tolerances than I'm likely to reproduce. I had a chunk of 1.5" 6061 aluminum bar left over from making the lathe tool post, so I cut it down to about 5 inches, which I thought would allow me to create plenty of travel for this project with room to spare for potential future uses. I didn't do anything more than knock off the sharp edges on the ends because it's not important that they're totally true. I marked the center line down the bar and began laying out where I wanted to make holes. The handpiece that I wanted to clamp in is 1 inch in diameter, so I marked the center for its hole 1.25 inches from one end. That's the same as I use for my lathe part, and it allows plenty of material on the end for drilling and tapping and creating a strong clamp. I also laid out a pathway for this piece to fit over the 12 millimeter rod and allow for adjustment of cutting diameter. I left around a 1/2 inch of material all the way around the pathway to be sure it would still be rigid once cut. I used the center drill to help me accurately start the hole for the rotary tool. Then I made the mistake of using a 1-inch hole saw to create a 1-inch hole. I have a 1-inch drill bit, but it always grabs material very hard, at times ripping things out of clamps and stopping drills, seemingly no matter what I do. I didn't want to deal with that, so I went with a hole saw. The hole saw works, but it made a hole that is actually larger than 1 inch with a rough finish, and it took a considerable amount of time to drill. Doing it all over, I would have used a smaller step drill that I have to go all the way through, and then use the 1-inch drill bit to finish with 2 big C-clamps clamping down the bar. That said, the oversized hole was nothing that I couldn't deal with. I moved on to drilling holes to help me create the pathway. I used a carbide burr and a rotary tool to connect the holes and remove the majority of the material. Then I spent entirely too long with files to smooth the edges of the path. I don't think it's that important, but I was trying not to create lots of play between the rod and the path, and it's harder and less fun to get carried away when hand filing. I cut the end of the tool holder down the middle with a bandsaw to remove some material and to create a clamp. Actually, I ended up making a couple of cuts to create a little wider groove for more clamping, since the hole for the tool ended up larger than the intended 1-inch diameter. I drilled all the way through the clamping area perpendicular to the cut with a 5mm drill bit so I could tap one side of the clamp to M6 by 1.0. One half was drilled to 6mm so a bolt could pass through without being threaded until it reached the other half. I went to clamp the handpiece into the tool and found that even with the wider clamping cut, it was still too loose to hold well. This was pretty easily fixed. I cut a section out of a soda can that's roughly 4/1000 of an inch thick and used that to shim the tool and get a firm clamp. I used a medium strength thread locker and a nut on the clamping bolt to be sure that it stayed in place even with vibration and chatter from the cutting process. With the rotary tool holder finished, I moved on to get the cutting assembly set up to allow me to mount it parallel to the brake surface and adjust the height or cutting depth. I drilled and tapped one end of the 12mm rod to M8 by 1.25, roughly 1.5 inches deep, so I'd have plenty of threads to install a bolt at varying depths. I then cut a piece of 1/2 inch inside diameter aluminum tubing to 1 inch, 2 inch, and 3 inch long spacers. Paired with the threads in the rod, these would give me an easy way to sandwich the tool holder between the spacers above it and a clamp below it at whatever height I needed. I used two 12mm collars to secure the rod and set the tool holder height. Once the rod passed through both the wheel bearings, I put a clamp style collar on to act as a stop, keeping the rod from moving down once set. Nothing prevents the rod from moving upward, but it is a very snug fit through the bearings that provides a lot of resistance, and I assume that I'd be putting more downward force on the cutter that I needed to prevent. If upward movement was an issue at some point, another collar could be added on the opposite side of the wheel to prevent movement in either direction, but this was never a problem for me. By the way, I used clamp style collars because I expect them to sit straight and centered on the rod. Set screw type collars are often cheaper, but may push to one side or sit a bit crooked. Centering wasn't really much of a concern for me, but I needed the collars to provide a surface pretty accurately perpendicular to the rod axis. The second collar was used as a stop to set the height of the tool holder. I started by marking where the collar would sit for the end of the carbide cutter to touch the top of the brake rotor mounts. Then I set my calipers to the total depth that I wanted to remove from the mounting surface, which was about 6mm, and made a mark there. I wanted to use a washer above the collar to better support the tool holder, so I set the top of the washer roughly even with a 6mm mark. None of this is incredibly precise, but I assume that it shouldn't have to be, because I'd need to set the position of the wheel later with spacers anyway. I was essentially just trying to make sure I could get close enough to allow me to move the wheel as needed. I put the tool holder in place with another washer on top of it, and then used a combination of spacers that let me use a bolt and washer to clamp the holder in place. One thing that I learned during the process was to be careful how tight the bolt is, or it could try to push the collar down and throw off the height setting. It didn't take much torque on the bolt to sufficiently secure the tool holder. As I was setting the tool up, I realized that the groove in my tool holder wasn't quite long enough to let me take off material as near center as I needed to, but I set it as close to center as I could and planned to elongate the groove later once I had most of the cutting done. Once it was all set up, I marked the wheel at 6mm below the brake mounts and made sure that the end of the cutter aligned with the mark, so that way I could be certain that my depth setting was correct. I attached the motor shaft to the handpiece and then put grease on the burr to help reduce clogging. I've tried paraffin wax, WD-40, and others, but grease seems to do just as well for me. I was finally ready to start cutting. As you can see, I decided to try to cut full depth all at once. I assumed that it would be slow going trying to make a full depth cut, but I was barely able to move the cutter. I tried everything from letting the tool do the work with minimal pressure, all the way to pushing until the burr's shaft was flexing. Nothing was very effective. Looking back, it may have been easier to cut this way if I had started from the outside and worked my way in instead. That way the cutter wasn't trying to remove quite so much material all at once. It took all of 1 minute and 5 seconds of attempted cutting before the handpiece fell apart. I have two Fordham number 30 handpieces. The one that I was using had never been used before, and the other has been used for a few years for at least equally stressful jobs and hasn't had a hiccup. Upon closer inspection, the two handpieces that are supposed to be identical are not. One is a little bit longer than the other one, and the groove patterns in the tools don't match. The chucks don't look quite the same either. Then I looked at the lettering. The tool that has worked for years has bold lettering and says Fordham 30 with a registered trademark symbol behind each word or number. The one that just broke says Fordham number 30. I paid full price for this from an eBay seller, but I think I got ripped off and received a cheap clone tool. Luckily I have the other one, so I just swapped it in. I adjusted the cutter to the same full depth cut that I tried on the last attempt. I thought that maybe there was slipping with the other cutter considering how it fell apart, so perhaps I could do better with this thing in place. Or maybe not. I adjusted the cutter to a more shallow depth, hoping that taking smaller bites would improve the process. To be honest, I didn't measure how much I was taking off on every pass, I just eyeballed or guesstimated what seemed reasonable to me. Once again, I started toward the center, and the first pass went pretty well. There was plenty of chatter and deflection, but overall it was getting the job done, and the cut looked okay. I left the height setting the same, but moved the cutter outward little by little and made passes until I was all the way through the brake mounts. The first cut had the most instability, which probably should have told me to work outside in, but I continued the rest of the process the same way. I kept working outward across the surface, stopping frequently to pop aluminum debris out of the cutter and apply more grease. It's easy to tell when aluminum is building up in the tool, even aside from visually, because it doesn't cut well and progress slows. I ended up making cuts at 4 different heights to reach the desired depth. The first 3 were something like 2 millimeters, and the last cut didn't remove much at all because I was hoping putting less stress on the tool would leave me with a good surface finish. You can very clearly see how much chatter and deflection there was with lots of these close-ups. Throughout the process, I made sure to go over each area back and forth a few times to make sure it was cutting where it should. Even as is, the finish turned out okay. It's not ultra smooth, but it's level and even. It may look like there are ridges between the cuts, but that's just the machining marks playing tricks on your eyes. Clamping the handpiece closer to the chuck may add a little bit of stability, but some handpieces will slow down or freeze up if clamped tightly in certain areas. Cutting the shaft holding the burr shorter looks like it may be a simple way to make the setup more rigid, or more ideally using a tool capable of holding bits with larger shafts. I still needed to cut further inward so the brake disc would actually fit, so I removed the tool holder to elongate the pathway. This time I used a large double cut burr to make quick work of it with minimal filing after. Then I set the tool up again and cut the remaining material at full depth. I removed the cutter and then thoroughly cleaned the wheel to get rid of all the aluminum debris and grease, and cleaned a section of the workbench as well so I wouldn't set the clean wheel right back onto aluminum shavings. The brake rotor fit as well as I hoped it would, and better than I expected it to. It was a good firm fit to keep the disc in position, but not so tight that it was difficult to remove or install, or that I think it should deform the disc. I did a test fit on the scooter, and the wheel was able to sit pretty close to center. But I now had a new problem. Now the center of the wheel was hitting the fork on the brake side, specifically the little nubs that were used to help locate and center the disc. Since the mounting surface was cut back, those little protrusions are no longer needed all the way to the edge of the wheel, so I set up the cutting tool once again. Unfortunately, the tool couldn't cut very much further inward. I didn't want to take a lot more material off of the tool holder, so the only easy option would be a larger cutter. I didn't have any larger diameter cutters that would fit the small chuck, so I tried using a sanding drum. That worked alright with a partial cut on one section, but the drum was stripped of all friction material before it could even finish the first cut on the second section. With multiple passes and sections to finish, I didn't think it made much sense to replace drum after drum. It's not critical that this area is perfectly level or concentric. So I finished the cutting by hand, taking the nubs down to roughly level with the center section of the wheel. That was enough to give me the clearance that I needed for the wheel to fit without contact. It was later suggested to me that I could have used cutting discs or saw blades that fit my cutting rig to take the entire center section out of the wheel, or to cut to a depth that I chose. I never thought about the small saw blades, and I don't think I've ever tried them. The discs did occur to me, but I was concerned that they may break if there was much chatter. Now that the wheel would fit, I had to deal with another issue for mounting the rotor. When I cut back the mounting surface, I also cut away the larger area for the shoulder of the brake bolts. Without modification, the bolts wouldn't be able to thread all the way in because the shoulder wouldn't fit in the wheel. I knew this was going to be an issue before I started the modifications, so I had already measured the depth and diameter inside of the wheel before I cut the material away. They were about 10 millimeters inside diameter and 6 millimeters deep. The shoulders on the bolts measured 9.85 millimeters and about 5 millimeters deep, so I needed to make a cutter that could remove at least a little more than that to create a pocket for the shoulders. I made this cutter in the past to cut pockets for O-rings and a bolt hole, and I thought that this idea may work, but in this case I wouldn't be able to have any section to act as a guide like this tool because it would damage the threads. This type of cutter doesn't require a lot of material or take too long to make, so I thought it was at least worth a try. I put a piece of 1/2-inch steel rod in the lathe and faced it off. You can see that the tool height was a little bit off because of the dot left in the center. The center of this shouldn't touch anything, so I left it as is and adjusted the tool height later. I marked the rod just over 5 millimeters from the end. With a 5 millimeter shoulder combined with the thickness of the disc, that should be plenty of room for the bolt. Removing only enough material for the depth of cut that I wanted would leave a shoulder to act as a stop when drilling. I cut that section down to 9.89 millimeters. I was actually going for 9.9, but that's close enough. I put a little angle on the very end, thinking that that may help me keep the bit centered when starting. Then I used the cutoff wheel to make a couple of shallow cuts at about a 45-degree angle, 180 degrees apart. These would create the cutting edges. I used a file to remove rough edges and went over each cutting edge quickly with a diamond hone. This type of cutter is not aggressive, but it should work, and leaving a lot of the diameter intact may help to make it more stable. I put a chamfer on each bolt hole before drilling, hoping that it would interact with the beveled edge of my bit and help me get it started straight and centered. The wheel didn't even come close to being able to fit on my drill press table properly, so I just went with hand drilling, and it was actually pretty quick to reach the stop. I cleaned the threads and then went through them with a tap. Once all of the holes were finished, I went over them with parts cleaner and compressed air, and then cleaned the entire wheel thoroughly before checking to make sure every bolt would go all the way in. I had to remove the seals from the wheel for machining, so those needed to go back in. They've never fit as tight as they should, again because the powder coater blasted those surfaces and changed the diameter slightly, so I used a little bit of sealant around the outside edges before installing them. The brake rotor location looked good to me at this point, so I installed it and torqued it to spec with thread locker on each bolt. I needed to make new spacers for both sides of the wheel next, so I reinstalled the wheel with an old spacer that was too short. I held the wheel so the brake disc was centered between the brake pads and then measured the gap between the spacer and the fork. Then I could add the old spacer's length to the gap that I measured and have a close approximation of the new spacer length required. I had a small amount of 1/2-inch ID steel tubing around that worked well for making new spacers. I faced it off and then cut the outside diameter to 20 millimeters so it matched up with both wheel seals. I parted off a longer piece than I thought I needed because I wanted to leave some room for error. I installed the wheel with a new spacer, and it was indeed too long, so I cut a little more off and test fit again and cut a bit more off. Once the spacer was centering the brake rotor in the caliper and the wheel was pretty well centered in the forks, I moved on to making the spacer for the other side. There was barely any room between the seal and the fork over there, so I used feeler gauges to measure the gap. Then I measured the distance from the top of the seal to the bearing face and added that to the gap to come up with the length of the spacer for that side. Again, I cut the spacer a little bit too long on purpose, but after a couple of test fits and shortening, the spacer fit as it should. The wheel was centered, or at least close enough for me, and it spun freely with the axle tightened. I've modified enough steel wheel spacers in the past to know that they rust pretty quickly. Even when I've tried clear coating them, it doesn't take that long for rust to set in. It could be that I used the wrong clear paints, but colored paints have held up much better for me, so my first thought was to spray paint both of the spacers black. I wanted to try something different though, and I've seen people heating steel parts and quenching them in different types of oils to create a dark oxide coating that resists rusts. It's usually called bluing or blackening. This seemed like a good time to try it, so I started by cleaning both spacers with acetone. I had a partial quart of motor oil left over from years ago that changed from amber to brown over time, so I decided to use it for quenching. I heated the first spacer with a torch using MAP gas until it started changing color, and then dropped it into the oil. Then I repeated the process with a second one. After letting everything cool, I removed both spacers from the oil and cleaned them. They took on shades of blue, purple, and brown when heated, and only got a little darker overall. The people that I've seen making dark black parts seem to be getting their parts quite a bit hotter, so I'm not sure if this treatment will provide much protection, but it's not that tough to redo it if I see the spacers rusting in the future. I assembled everything with thread locker to wrap up most of the wheel swap. The wheel isn't exactly centered in the forks, but it looks like it's about 1/32 or roughly 0.8 millimeters or a little less than that off center. Close enough for me. There was still one thing left to do, which was the speed sensor setup. I use a Trailtech Vapor, which requires a magnet that I've epoxied to the rim and a sensor that needs to be positioned very close to that magnet as it passes. The old mounting location for the 12-inch wheel didn't match up anymore, and the distance to the sensor was a little off as well, so I peeled off the old sensor that was attached with 3M double-sided mounting tape. I just folded over Gorilla Tape to space out the sensor in the past, but I wanted to come up with something better this time around. I had small pieces of PVC pipe around that pretty closely matched the curvature of the fork and the sensor, so I cut a chunk out of that to act as a spacer. One piece didn't get the sensor close enough to the magnet to pick up a signal, so I cut a second matching piece to stack, and that did the trick. I used JB Weld to glue the pieces together overnight and gave them a coat of flat black paint. Then I applied double-sided tape to the sensor and to one side of the spacer and stuck everything to the fork. I added a cable tie to apply mild pressure for a little insurance. Then the speedometer settings had to be changed because the gauge uses the signal from the sensor combined with the tire circumference to calculate and display speed. I used the calculator on my site at 49ccScoot.com to find the circumference of the 130/60/13 front tire and entered that into the Trail Tech. Calculated numbers like these are often close but not quite right, so I always take a ride with a GPS or phone app to compare with my speedometer. I look at the trip odometer reading rather than live speed or top speed because I've had more accurate results that way. After the ride, the Trail Tech said I traveled 6.6 miles and the app said the same. Max speed was a half mile per hour different, but again, I go by the odometer reading. I didn't need to make any changes this time, but if you use this method and need to adjust wheel settings, I have a calculator on the site to make that easy as well. Just enter the setting that you're currently using, along with both odometer readings, and it will tell you what the corrected setting should be. At that point, everything was finished and ready to ride, but I did get curious to do one more check. I wanted to see if the front and rear tires were centered with each other, so I set up the old-fashioned string method to give me some idea. I tied a long string around the rear tire and taped it to the tire. Then I pulled the string ends up to the front and wrapped them around a metal ruler, keeping the string at the width of the rear tire, which is 140 millimeters or about 5.5 inches. Once pulled taut and centered against the front tire, while also ensuring that the string is touching 2 points on each side of the rear tire, you can see if the tires are aligned with each other. In my case, it appears that the rear tire sits maybe as much as 1/4 inch to one side, which you can also see just by looking straight down the side. Since the front wheel is very near center, I would think the best solution would be to move the entire engine over. Less spacing behind the wheel doesn't look like an option because everything is already packed in there pretty tightly. The front wheel could be moved over to match the rear wheel, but then I would be intentionally putting that off center of the scooter. I don't really think it's worth taking action at this point. It's likely been about the same alignment for at least the time that I've had the RC1 in the scooter, and it feels fine to me. It may even be similar with the stock engine and wheel, but I've never checked. I'd honestly be a bit surprised if scooters, especially Chinese scooters like mine, are perfectly aligned even when they're new. With that said, I'm going to wrap this video up here. I hope you've enjoyed watching my project, and if you have, or if you've learned something, please give the video a like. Hit the subscribe button and click the bell to receive notifications so you won't miss any future project. Thanks for watching.